Let's talk about solving for a variable in terms of other variables. Sometimes you have an equation that contains more than one variable. Now, our other examples that we did so far was linear equations in one variable. So you have only one variable and you're solving for a constant. Now, in this case, let's think about this as you have more than one variable and you're trying to find out that variable in terms of the other. As an example, there are such examples. You have the simplest case, x plus y equals 2. This is very common that you would deal with x and y because they provide linear equations. They provide an equation for a line. So later on, when you're asked to find out the expression for a certain line, the equation contains x and y, and we will try to solve either for x or y to write the equation. So this, you're given the equation x plus y equals to 2, and they ask you to find out what is x. That means find out x by itself, isolate x, figure out what is x in terms of the other variables. You can think of the other variables as numbers. You do exactly the same as what you did for linear equations. You think that y is a number. If it was something like x plus 3 equal to 2, what would you do is you subtract the 3 from both sides. And you can figure out x equals negative. So I'm going to think about this equation as if y was a constant, and I will try to solve for x. What do you do? Isolate x by subtracting y from both sides. What you get is x equals 2 minus y. In the case when you had 2 and negative 3, you can add them up and get negative 1. Here, 2 and negative y, they cannot combine to each other, so you will leave it as it is. So what is my answer? I figured out y in terms of the other one. So the answer is x is equal to 2 minus y. Left side of the equation is variable x. The right side of the equation is every other variable. It doesn't have to have a nice form. In this case, 2 minus y is easy to see, but sometimes it could be fractions. As long as it doesn't contain the variable x, you have solved for that specific variable. I found out what is x. X equals 2 minus y. So I've answered the first example. How about the second example? I equals 2xy, and they want you to solve for y. Again, I will think of every other variable as constants. If you had I was 3, 2 times 5 times y instead of x, what would you do? You divide both sides by 2 times 5. You can multiply 2 and 5 if you want. These two will cancel out. And I figured out what is y. Y equals 3 divided by 2 times 5. I'm going to do exactly the same here and say, let's get rid of everything that is a coefficient of y. So I'm going to divide. You cannot subtract because it's multiplication. I will divide by 2x on both sides. The 2's will cancel out, the x's will cancel out. I isolated the y by itself. What is y? Y ended up to be I divided by 2x. Again, if your variable is isolated by itself, then you answer the question, what is y? Y equals I divided by 2x. It depends on the other variable, I and x. Whatever I pick for I and x, I can figure out what is y. Oops, I answered this question. Y equals I over 2. It looks very simple, and you can think about it as numbers always, whatever you do. How about this one? A equals v times x minus wy. And first they want you to figure out what is w. If there were numbers, what would you do? You distribute this number coefficient as if we were simplifying and solving an equation. I will distribute the coefficient. So let's do that. A equals v times x minus v times wy. This is exactly what you do if there was 3 as a coefficient you distribute. So now, what do I want? I want to isolate w. So I'm going to get rid of every other term. This term does not have a w. I'm going to get rid of that by subtracting it from both sides. This is the only term that contains w. I'm going to keep that. So these two will cancel out. What do I have on the left side is a minus bx. They cannot combine to each other, so I'm going to keep it as it is. Right side, what is left is minus bw. Okay. Again, what am I trying to find? I'm trying to find w. So what do I need to get rid of? I need to get rid of b and y. I will divide by b as well as y. I will divide by b, in this case minus b and y. These two can cancel out. These two can cancel. Here's one thing that you should be careful. I'm going to write it here so you can see. If you have 1 plus 2 divided by 2, you can never cancel out these two. If you do that, what you get is 1. Right? Well, actually it's 1 plus 1, but let's say either you'll get 1 or 2, depending on how you think about it. But if you add them together, 1 plus 2 is 3 over 2. 3 half is never equal to 1 or 2. If there is an addition or subtraction in the numerator and denominator, there is no cancellation possible. You cannot cancel out each term separately. You can separate these guys and write it as two separate fractions. Say this is 1 half plus 2 over 2. Now I can cancel out this and say this is 1. You can never cancel out these two. So if you look at the first equation, fraction, you cannot cancel out the negative b's together, because this is a minus subtracted b. So what do I have? It's a minus bx divided by negative by equals right side. Those guys will cancel out since there is multiplication. If there is multiplication, it is possible to cancel w. So did I find w by itself? Yes, I did. With w, w equals a minus bx divided by negative bw. It doesn't look that nice, but you solve for w by itself. It doesn't depend on anything else. It only depends on the variables a, b, x, and y. Singled out w. Okay. The whole purpose of this subject is just to isolate that specific variable. As we go on later, we will need that to solve equations. If you have more than one variable, you try to isolate one of the variables. Again, as I said earlier, this is a form that we will see very commonly when we're dealing with the equations of y. 4x plus 2y equal to 5, and they ask you to find out what is y. I think you might have seen it with mx plus b. This is equation used commonly for line, equation of line. Y intercept form of equation of line. So normally you would try to isolate y to find out the equations for a line. So here, these examples are just to prepare you for that. It looks very simpler. What do I want to do? I want to isolate to y. So I will start with subtracting 4x from both sides. By doing that, these two will cancel out. What is left on the right side? Left side is 2y. On the right side, I have 5 minus 4x. What is the next step? Next step, I want to get rid of the 2. I'll divide those by 2. What is y? Y equals 5 minus 4x divided by 2. Again, be careful. You cannot simplify these two. You cannot do that. Okay, this is 2. Because there is a subtraction here in between. What you can do is either leave it like that, or you can separate them and say y equals 5 half minus 4x divided by 2. You can break down the fraction into two separate fractions. Now I can simplify it and say y equals 5 half, doesn't really simplify, but 4x over 2, I can cancel out the 4 and 2. Okay. Alright. I mean, not cross it there. 4 divided by 2 is simply 2x. So can I answer the question, what is y? Yes, y equals 5 half minus 2x. Again, this was totally fine, but normally you want to simplify it as much as possible. So I answered the question, what is y? Okay, let's look at the next example. 3x minus w equals, let me shift this up a bit. 3x minus w equals ax minus w, and you want to find out what is x. This might look a bit more complicated than the other one, but there is always the same idea. What do? You want to isolate x, since we're solving for x. And here you have more than one x. Which one are you trying to isolate? So before I get into this, I'm going to show you a linear equation that you solve normally. Let's say you have this equation. You're given 2x plus 4 equals to 3x plus 4. They ask you to solve this equation, what do? You get rid of the 4 by subtracting 4. As well as you want to get rid of this 3x. You want to have all the x's on one side, all the other constant on the other side. So you subtract the 3x as well. Again, you can do it in 2 steps, or you can do it in 1 step. These two will cancel out. 2x minus 3x, negative 1x. Right side, negative 3x and 3x will cancel out. 1 minus 4 is negative. And then you divide by that negative 1, and you find out x equals 3. The solution doesn't really matter. The step matters that you moved all the x's to one side. If you want to isolate x, you move all the x's to one side. So if I want to isolate x, I'm not going to keep an x on the right and a 1 on the left. I'm going to move them all to one side. It doesn't really matter if it's left or right. I'm going to subtract ax from both sides. Let's do that to see what happens. These two will cancel out. Now I have 3x minus ax, and there is still minus w, and right side there is negative y left. These two have cancelled. Again, you try to isolate x, so I'm going to get rid of that w. I'm going to add w to both sides. These two will cancel out. We get 3x minus ax equals w minus y. Negative y plus w, or w positive y minus w. Doesn't really matter. Okay, what is x now? How do you find x? Can I divide both sides by 3? If I do that, I cannot cancel out these two, by the same reason there is a negative sign in between. If I divide by a, I cannot cancel out these two, by the same idea that there is a subtraction. So what can I do? Go back a bit. Okay. What can you do is, how would you add 2x and 3x? Say 2 plus 3 is 5. You say this is 5x. But you can think about it as, what if these two have x in common, and I factor the x? What is left from the first one is 2. What is left from the second one is 3. 2 plus 3 is simply 5. This is how you get the 5x. You factor out the common term. So here, these two, 3x and ax, they both have an x in common. So I'm going to factor that x. What is left from the first one? This is 3. What is left from the second one? Negative a. If you distribute 3 times x times 3 is 3x, x times negative a, negative ax. So I haven't changed anything, just factored out the common term, which is the variable x. That's the one that we want to solve for. And right side, still the same, y minus w. Here, now, I can get rid of 3 minus a, since there is multiplication here. I can divide both sides by 3 minus a. By doing that, these two will cancel. And I've solved for x. I've singled out x, or isolated x, however you want to call it. 3 minus You see the right hand side does not have any x in it. It only depends on other variable. So figure out what is x. X equals w minus y divided by 3 minus. Okay, it is important that make sure that the right hand side does not contain x. If you're solving for x, it shouldn't depend on itself. You cannot say x equals 2x plus 1 divided by 3. This doesn't make sense that you're solving for x and on the right side you still have an x. Okay, you have to have all the x's on one side. Okay, so this is not a way to solve. Let's look at the next example. What if there is a fraction? Normally you do exactly what you do when you're dealing with linear equation. First get rid of the fraction. Doesn't really matter what it is. You can always multiply both sides. In this case, what do I multiply it by? I will multiply it by the common denominator. Here, denominator is 1 really, that much. So I will multiply 3x plus w to both sides. 3x plus w. By doing that, I will have, I'm going to write it in two steps so you can see 3x plus w times 2x minus y divided by y is that line, not the straight line. Divide by 3x plus w. Now on the right side, you'll have zy 3x plus w. Divide by 1 really doesn't make any difference. Again, why did we multiply the 3x plus w? So we can cancel it out. You might say, well, there's addition. Why can I cancel this and not the other one? Here, this whole two terms are equal to each other and there is a multiplication between these two. You can look at each one as this is a box multiplied by another box. I can cancel out these two. I cannot cancel out the 3 x's and leave the w's. I have to consider the whole thing as one. Okay, let's continue. What do I have is 2x minus y, right side, zy 3x plus w. We go further, we distribute the zy, so you have 2x minus y, zy times that, zy times the second one. I'm going to put them in order, 3 zy x. I put the constants up front all. W times zy is plus zy w. Okay. Well, what are we trying to solve for? We're trying to solve for y. So I'm going to move every y to one side, every other term to the other side. So here, this term contains a y, this term contains a y, this term contains a y. I'm going to add a y to both sides, so I can move everything that has a y to one side, so plus y plus y. What we have is 2x equals 3zy x plus zyw plus these two cancelled out already. There's a y. We added a y to both. Okay. How do we solve for y? Exactly the same as the last idea. What do? You factor the y in common on the right hand side. So I have 2x on the left side. Cannot do anything with that. Right hand side, every term has a y in common. So factor out the y. What is left? 3zx from the first one. Plus, if I take out the y from the second one, this is zw. Do not close the parentheses because the last term still have something. The last term is 1 times y. So you should say plus 1 still there. The only way to get that y is if you have a 1. 1 times y is plus 1. So what is 2x? What is y? If I want to find y by itself, I will divide it by this whole thing. 3zw plus zw plus 1. I will divide this equation on both sides. 3zw plus zw plus 1. These two will cancel. And I've figured out what is y. What is y? Y is simply 2x divided by 3zw plus zw plus 1. Sorry, this is 3zx, not zw. I made a typo here. This is not a w, this is a. Fix that for the. Make sure that you don't make the same mistake later. There's an x here. We divide by 3zx, and these two will cancel. Okay, so we found out what is y. If you look at the right hand side, there is no y in the right hand side. Again, make sure that the y is isolated. So in one side that. Okay, this might have been the most complicated case. Every other term is very similar to these. So all these examples are always the same. You isolate the variable. Every term that contains a specific variable that you're looking for to one side, everything else on the other side. If it needs factoring, you factor. Yeah. Always get rid of the denominators if you're dealing with fraction. Makes the work much easier. Okay, I'm gonna stop here and continue next time on the application.